People take inspiration in all sorts of creative work, such as programmers go to open source communities to borrow snippets of codes, scientists review literature to identify areas of innovation, and artists navigate galleries to gain inspirations. Creative workers advance their work by knowing what have been done, learning lessons from the previous and their peers, and further improve their own work from building on those examples. People take inspirations differently. For example, given various skill levels, in a previous bus stop design study where architecture students and experts were given a selection of images from 4 categories that were either other bus stop designs, architectures, product designs, or random pictures from nature, and asked to choose one image as an inspiration, then they sketched a concept for a new bus station. Researchers found that, compared to architecture students, experts were more likely to select examples from the same category, and students chose more further inspirations. People prefer examples at various conceptual distances when seeking inspiration. How do people leverage conceptual distance to seek inspiration for their own creative work? When inspirational, we mean helpful to an individual when creating their own idea. Inspiration is relative to an individual's cognition and context. Some examples inspire certain individuals more than the other. For example, in the instance of designing a bus station, a near stimuli of bus station with seats may help people think of adding a waiting area in their design. When people are exposed to a far stimuli such as a biological structure, they may borrow the structural feature and design a spiral lane for the bus station. There are many online galleries that allow people to share ideas and learn from each other. Designers look for novel features and concepts for inspiration. They are organized around themes, styles, keywords, etc. However, these galleries are not organized around conceptual distance with respect to individuals' ideas. How might we visualize a large repository of examples with respect to an individual's ideas to illustrate the existing design space? Specifically, we look at various ways to illustrate the existing design space through visualizing conceptual distance and study how people leverage it for their own creative work. How do people explore the examples, and what effect does it have on how they iterate their ideas? We constructed the system called IdeateRelate that provides adaptive visualization for people to explore examples based on their idea input, hosted using Python Flask. People can explore the examples in the visualization area, where each dot represents an idea. They can hover over individual dots to read, and click to curate for later idea iteration. There are 2 notions of conceptual distance. The first is that is this example in the same category of participant idea? The second is that how similar or different is this example compared to the participant's idea? We construct the system interface based on these 2 notions of conceptual distance categorization and semantic. On the left, you can see a legend of different categories labeled with different colors. Each dot is represented with a color coding on their category. All of the examples are viewed with respect to the individual's idea along the x-axis. Participant's idea is placed on the most right position of the visualization. On the left are the examples more semantically far from participant's idea, and on the right are the examples more semantically near. We constructed a repository of examples from an online volunteer matching website related to COVID-19. We collected over 700 ideas, and after removal of invalid examples, such as non-English, we kept a total of 635 examples in our database. We also had 2 researchers to code the categories of examples using an existing paradigm of a COVID-19 related project's website. We used Python Natural Language Toolkit to extract keywords in example descriptions and ideas, used a state-of-art NLP algorithm to extract feature vectors from these, and calculated pairwise cosine similarity to get semantic distance. We run an evaluation study to examine how people explore examples using our system. Participants were presented with a problem brief to brainstorm an idea related to COVID-19. Then they propose an initial idea as a seeding idea to explore the example space. During the stage of exploring and curating examples, they either had access to the visualization that emphasized conceptual distance in relation to their idea or not. Last but not least, they review the curated examples and iterate their ideas. After the study was done, 2 independent design experts rated the ideas based on creativity. We investigate these 2 questions in the evaluation study. How do creators leverage a visualization that emphasizes conceptual distance to explore examples compared to a list? How do people curate examples to help them improve their own ideas differently when using a visualization versus a list of ideas? Our result shows that, Compared to participants who only had access to a list view, participants who also had access to the visualization tended to explore examples more similar to their own. To give an example how people used curated examples in their iterated proposal, this participant used details from the curated examples and combined those with the initial idea in the iterated proposal. The initial proposal on the left is about classroom setting in pandemics. Then they curated ideas that were about virtual event space, social hour, matching people, and a mural board to contribute ideas. Their iterated proposal not only built on the initial ideas by adding more details, but these details were specifically coming from the examples they curated. To summarize, creators find value in leveraging cues about conceptual distance to explore examples. They used data about conceptual distance to explore primarily similar examples. More language from those ideas were adopted into the revised ideas that the examples had more influence. Our independent ratings show that the revised ideas in the visualization condition were rated equally novel even though they used more language from the examples. We propose following questions as potential directions for future work. What kind of cues or associations can be surfaced to help ideators find relationships between ideas? How might we design for ideators who have multiple ideas or parallel ideations? How might the design be adapted to collaborative ideation settings, or in the context of project-based learning where students work in teams? Thank you. You may find more details about our study from our paper.